Guys, Mr. Bowman here. We are carrying on with 1.2 MCAT Algebra, and we're focusing on all the excellence questions from that 2020 exam. So we're going to jump straight into question 29, one of my favorite types of questions because it just says solve this. And just looking at the question, I've got two fractions, some addition, and I know I'm going to have to use the bottom times bottom and then do the cross multiplying as well. So bottom times bottom is going to leave with a quadratic. So I think this is going to be a messy quadratic question. So let's see if that eventuates. So we've got 3 over x plus 2. There's my first fraction. Plus 5 over x minus 4. There's my second fraction. When is that equal to 2? So two fractions adding together. We do bottom times bottom. So it's going to be x plus 2, x minus 4. I then cross multiply, so it's going to be 3x minus 4, and then the other way around as well, plus 5x plus 2. And we've been asked, when is that equal to 2? We're going to expand and simplify the numerator. So that's going to leave us with 3x minus 12 plus 5x plus 10. And at the same time, this denominator here is just division. I'm going to move it to the other side as multiplication. So that's going to be 2 times those brackets that I'm getting out the way. At this step here, I'm now going to simplify the left-hand side. At the same time, I'm going to expand the right-hand side. So that there is 8x minus 2, and that should be equal to 2x squared minus 2x minus 8. I'm now going to expand the right-hand side, nothing to do on the left-hand side at this stage. So I've got 8x minus 2. When is that equal to 2x squared minus 4x minus 16? Looking much better at this stage. I'm now going to move this over to the other side because to solve a quadratic, I need one side to be equal to 0. So I'm going to go minus 8x under those x's, and plus 2. Those and those cancel me with 0. 0 equals 2x squared minus 12x minus 14. These all here have a 2 in common, so I'm just going to factorize out that 2. So we've got 2 bracket x squared minus 6x minus 7, and I can get rid of that 2 as well, x squared minus 6x minus 7. So carrying on over here, I can factorize now. So 0 is equal to x minus 7 x plus 1, and that's because negative 7 plus 1 multiplies to the negative 7 here, adds to the negative 6 over there. And from that, my two answers, so the first answer will be equal to positive 7. The second answer will be equal to negative 1. So I've got two answers here. Quadratics, often you have to think, is there a reason one of them could be a false answer? In this case, the denominators are the only reason it could be a false answer, because if a denominator ends up being equal to 0, you can't divide by 0, so it's a wrong answer. But that would only happen as if that was negative 2 and if that was 4, which neither of these are our answers here. Question number 14, again a nice question because it's just asking you to solve something. Let's get into it. So we've got 8x, or 8 to the power of x times 4 to the power of x squared minus 6x. I'm seeing an x squared in the power, so I'm thinking it's going to be a quadratic again. When is that equal to 4? So initially when I looked at this question, I was a bit confused because I was going, well, 4 to the power of 2 is 16, but how can I get that there? But then I realized all of them are 2 to the power of something. So I'm going to need to change this. So that 8 is going to be 2 cubed to the power of x. That 4 here is 2 squared to the power of x squared minus 6, and that 4 there is just 2 squared. Simplifying the right-hand side is where all the work's going to be, or the left-hand side, that's where all the work's going to be here. So we're going to expand the brackets by multiplying. So 2 to the power of 3x times 2 to the power of 2 bracket the second power equals 2 to the power of 2x. Adding together the powers, I won't bother simplifying this brackety part at this stage, but we're going to have 2 to the power of 2 bracket x squared minus 6 plus 3x, because I'm adding the powers together, is equal to 2 to the power of 2. Cancel out the bases, and that leaves us with 2 times x squared minus 6 plus 3x equals 2. I can now here start simplifying. I can see where the quadratic part's coming up, so I need to simplify and make it equal to 0. So that's expanding the bracket, 2x squared minus 12 plus 3x minus 2 is equal to 0. That minus 2 is the opposite of that positive 2. And that is going to leave me with 2x squared plus 3x minus 14. When is that equal to 0? That 2 makes it annoying, so I've got to use the grouping method to solve this. So 2 times negative 14 is equal to negative 28. So we need to think what multiplies to negative 28 adds to positive 3. Hopefully you're thinking negative or positive 7, negative 4. So I'm going to replace the 3x with 7x and negative 4x. So I've got 2x squared plus 7x minus 4x minus 14. When is that equal to 0? Factorizing the two parts separately. The first part, they only have an x in common, leaving us with 2x plus 7. The second part has a negative 2 in common, leaving us with 2x plus 7 equals to 0. I like this because the same bracket's coming up twice, which means I didn't make any math errors. So that common bracket, 2x plus 7, goes there. The leftover bits forms a new bracket. So we've got x minus 2. When is that equal to 0? So I'm nearly there. I now need to find just the two solutions. So I'm going to do that working over here. So 2x plus 7 equals to 0. That'll give us the first answer. X minus 2 equals to 0. That'll give us the second answer. So we're going to go minus 7, minus 7. 2x is equal to negative 7. Divide by 2, divide by 2. My first answer for x is equal to negative 7 over 2. My second answer, this one's a bit easier, plus 2 plus 2. The second answer for x is equal to positive 2. On to question number 41. We've got an equation. We've been asked to solve it. There's some squares all over the place, so I'm guessing it's going to be a quadratic inequation as well. So let's get into it. So we've got the first bracket, which is 3x minus 5 squared. When is that equal to or less than 3x squared plus 1? So first step, just going to double bracket that perfect square to make it easier to expand. So 3x minus 5, inequality sign, 3x squared plus 1. Expanding the brackets, we're going to have 3x times 3x, that's going to be 9x squared. We're going to have negative 15x and another negative 15x from that expanding, which is going to give us to negative 30x. And I'm then going to have minus 20 or positive 25. When is that equal to or greater than 3x squared plus 1? I'm now going to simplify this. I'm going to go 3x squared, take that away from both sides, which cancels out this, and I'm going to do the same with that 1, make it a minus 1, minus 1. So we've got 6x squared minus 30x plus 24. When is that equal to or greater than 0? I'm now going to expand, or actually I'm going to do the opposite of that. I'm actually going to factorize out because I can see 6, 30, 24. They've all got a common factor of 6. So I've got 6, open bracket, x squared minus 5x plus 4. When is that equal to greater than 0? And we can now get rid of that 6. X squared minus 5x plus 4 equal to greater than 0. And at this point here, I can factorize minus 4 minus 1 equal to or greater than 0. So at this point here, I can't actually solve quadratic inequations, so I've got to do it visually using a graphing type method. So what I'm going to do is I'm going to turn this into an equation to find out the x-intercepts for my parabola. When is it equal to 0? So x1 will be equal to 4, x2 will be equal to 1. So let's sketch a parabola. Thinking up here, it's a positive parabola, and we want to know when is it less than 0. So there's my graph, there's my parabola. So there's the first x-intercept of 1 and the second x-intercept of 4. And as I said before, we're looking for when it's below less than 0. Sorry, I think I might have been saying greater than 0 throughout the whole question, but when is it less than 0? In this case, it'll be when it's below the x-axis, that'll be anything kind of greater than 1 but less than 4. So therefore, my answer, 1. And don't forget your inequality signs, greater than or equal to x, which is greater than or less than 4. So when is it above 1 and below positive 4? Question number 42. We've got a rectangular piece of paper, and that's represented by the corners here. And then this corner's been folded over here, resulting in kind of this shaded area in grey over there. So it looks a bit messy. We know the following lengths, and they're all represented in the diagram, so I won't worry about those too much. And we've been told about the area of a triangle. We've been asked to find the value of x, so the shaded area, that's the shaded area I mentioned before, is 24. So pretty messy question, but generically what they're asking for us is the area is going to be, or the area of the shaded one, is going to be that rectangle. And made that times sign minus 2 times that triangle. Thinking about all of these here, we've got the area, the rectangle, 2 lots of the triangle. We're either going to come up with numbers or algebraic expressions for them based on the information we have in that diagram there. So the area, that's nice and easy. We've been told that it's 24. So 24 is equal to the area of the rectangle, which is base times height. So that's going to be an expression. So that's going to be 2x minus 5, x plus 3. And then we're going to go minus 2 times the triangle. And the triangle down the bottom is really height of 3, height of 2, base of 3. So it's going to be times 1/2 times 2 times 3. So that's the area of the one triangle, and we're going to double it for that folded portion. The nice part here is the 1/2 and 2, they cancel each other out. So that means 24 will be equal to, let's start expanding this here, 2x squared plus 6x minus 5x minus 15, and then minus 6. Because quadratics need to be equal to 0, we're going to go minus 24 minus 24. So 0 is equal to 2x squared plus x minus 45, because we've got 21, 24 gets us to 25. We're now going to factorize ours by using the grouping method. So 2 times negative 45 is negative 90, and 10 and negative 1 add to the positive one here, multiply to negative 90. So let's split up the 1x into 10x and negative 9x. So 0 is equal to 2x squared plus 10x minus 9x minus 45. Factorize our groups. So group number 1, group number 2. 0 is equal to 2x, x plus 5. And then these have a negative 9 in common, x plus 5. This is good. I didn't make any mistakes because the same bracket's coming up twice, which means 0 will be equal to x plus 5. That's the matching bracket. And the leftover bits, 2x minus 9 forms the second bracket. 2x minus 9. I can now solve for my two solutions. So x1 is easy. That's going to be negative 5. And we might have to do a bit of solving here. That's equal to 0. So we've got 2x equals 9. X equals 9 over 2, which is equal to 4.5. So I've got my two solutions, x2. I just need to think, are any of them false solutions? And in this case, x1 would be a false solution. And that's because if we put x1 into this one here, negative 5 plus 3 is negative 2. A side of a rectangle can't be a negative dimension. So x plus 3 can't be negative, which means x can't be equal to negative 5. Therefore, in our case, x is equal to 4.5 centimeters. So question number 43. Terry is 5 years old and Murray is 4 years older. So that means Murray will be equal to 9 years old. How many years will it take until Terry and Murray's age in years multiplied together to get 77? Gosh, this is going to be a bit of a headache. So what we're going to do is we're going to start off by saying, so let x equal the time passed in years. And that's what the question was asking us about, was saying in how many years. So how long or how much time has to pass for their two ages to be multiplied together to get to 77. So generically what we're going to do is we're going to go Terry's age times Murray's age. When does that equal to 77? Terry's age is currently 5, and in that time their age is going to become x plus 5. So it's going to be x, the number of years that have passed, plus 5 to get to Terry's age when they get to 77. And Murray's going to be the same. That's going to be x plus 9. So our expression, so we're going to have x plus 5, x plus 9. When is that equal to 77? And at this stage here, we actually have quite a nice quadratic. So let's expand this bracket. So we're going to have x squared plus 14x plus 45. When is that equal to 77? We're going to subtract 77 from both sides. So we've got x squared plus 14x minus 32. When is that equal to 0? Factorizing that, what multiplies to negative 32 and adds to this positive 14? Hopefully you're thinking 16 and negative 2. So we've got x plus 16, x minus 2, that's equal to 0. My answers are x1, negative 16, x2 equals 2. Thinking of the context, this negative number doesn't make sense. So in 16 years in the past, Terry would have been negative 11 years old, and Marie would have been negative 7 years old. These people, you can't have a negative age. That's not how that works. So that there is a false answer. So we know that x can't equal to 16, or negative 16 rather, and that's because Terry and Marie can't have a negative age. So therefore, x is equal to 2. And what that means is in 2 years' time, Terry and Mary's ages will multiply to 77. For the final question, or the final excellence question from that 2020 MCAT exam, and we've been asked, with this messy equation, we've been asked to get x in terms of c, p, and y. So just a reminder, that means x equals something to do with c, p, and y. So we're going to do a bit of rearranging here. So let's start off with by jotting my equation down. So we've got y plus 3 equals the square root of c x squared minus 7, close bracket, over p. So I'm going to start by getting rid of this square root, and that's by squaring both sides. So that means y plus 3 squared should be equal to c times x squared over 7 divided by p. We've still got more issues. That x squared is still locked away on the numerator, which means I need to get rid of the denominator. So I'm going to go times p times p. So we've got p bracket y plus 3 squared is equal to c x squared minus 7. We're still problematic because that x is still locked away in another bracket, so I need to get rid of that c now. So I'm going to go divide by c. So p y plus 3 squared over c, when is that equal to x squared minus 7? Getting a bit better, I can now go plus 7 plus 7. So we've got p y plus 3 squared over c plus 7. When is that equal to x squared? Oh, that's a funny squared. And finally, I can get rid of that square by square rooting both sides. So square root, square root. So x will be equal to the square root of p times y plus 3 squared over c. And if you have a look, that actually does resemble a little bit what we had here, except, or actually, just realized, so divided by c plus 7. So I've got to extend that square root, can't miss out that 7 there. So it does resemble a little bit what we had here, but changed around. So that wraps up the 2020 excellence questions. Hopefully you found them useful. Make sure you have a look at the excellence questions from the other years. They're all really, really helpful. Don't forget about the merit and excellence stuff, which may also be of assistance. If you do have any questions, just let me know in the group, on the chat function, or the comment function, whatever it's called, and I'll get back to you when I can.